Okay, so this is our second lesson in our third unit. Oh, we should change that up here. This is going to be Unit 3, Lesson 2, which covers polygons. So our learning goal for this lesson is this. We'll be able to name polygons and then find the sum of the measures of their interior and exterior angles. All right, so let's begin with some basics. Let's talk about what a polygon is. When we think about a polygon, um, it's kind of like defining a rectangle. Like we kind of know what it is, but how do you really define it? So when we talk about a polygon, it's defined as a closed plane figure. Now when I say plane, I don't mean boring. I mean it's flat, like it lives on a plane. So it's a closed plane figure, and it has to have at least 3 sides. The way that we name a polygon is we name it in order using all of the vertices. And when we name it using the vertices, we name it in order. So for example, I might call this polygon A, B, C, D, E. So you can see I'm going in a clockwise direction, A, B, C, D, E. Now we could also call this polygon C, D, E, A, B, because I'm starting at C and I'm going in order around the polygon. All of those would be acceptable names. Usually we don't even put the word polygon in front. We would just say, okay, here we have this figure. We might call it figure A, B, C, D, E, and that's acceptable as well. Okay, so that's how we name a polygon. We used capital letters because those represent the points that are the vertices of the polygon. So thinking about your left-hand column questions, I think this is pretty obvious. What is a polygon? Goes on the left over here. Okay, now there's 2 different types of polygons. The first one is what we call a convex polygon. And convex has to do with the shape of the polygon. Now, the specific definition of a convex polygon says if I'm going to draw all of the diagonals of the polygon, hang on here a second, if I'm going to draw all the diagonals of the polygon, none of those diagonals are going to contain points outside the polygon. So when I say diagonal, a diagonal is a line that connects 2 vertices, but not 2 vertices that are right next to each other or 2 vertices that are adjacent. So I want to connect every vertex to every other vertex like I'm doing right here. You see that? And if I construct all of these lines, all the lines that go from one vertex to every other vertex, notice how every single one of these lines is inside of the polygon? Well, if that happens, then we call the polygon convex. Every single diagonal is inside the polygon, then it's convex. Now, the alternative to that is concave. So a concave polygon has 1 or maybe more diagonals that contain points that are outside of the polygon or in the exterior. Now, if I start from this vertex here and I draw in all the diagonals, like I draw one here, here, those 2 diagonals are both inside. But let's say I start from this vertex down in the lower right-hand corner. If I draw a diagonal here, okay, that's inside. But when I try to draw the diagonal from this vertex to that vertex, boom, right now, this diagonal right here is outside of the polygon. That makes it concave. So thinking about definition that goes here, or a question that goes here, you might ask, what's the difference between a convex and a concave polygon? So that's kind of a level 2 question. Not just what is a convex polygon or what is a concave polygon, but what's the difference between the 2? All right, we also have to know the names of all of the polygons. So you might know some of these. If you want, this would be a great time to pause the video, draw this chart, and fill in all of the sides or all of the names of polygons that you think you know. Because I'm just going to go through here and reveal these. But if you think you know some of them, you should try to access that information in your head before we go over it. Of course, a 3-sided polygon is a triangle. 4 sides we call a quadrilateral. Now there's lots of different types of quadrilaterals, rectangles, squares, rhombuses, parallelograms, all sorts of different types, but the main name for anything that has 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon with a P, so very close to a hexagon, but the prefix is slightly different. 8 sides is an octagon, like an octopus. 9 sides is a nonagon. 10 sides, decagon. 11 sides, undecagon. 12 sides, dodecagon. So your question up here, what are the names of the polygons up to 12 sides? After 12 sides, we stop naming them and we just call it an n-gon. Um, or, or for example, if something had 15 sides, I'd call it a 15-gon. All right, now let's talk about the interior angles of a polygon. We already know that the angles of a triangle add to 180, right? So for example, the measure of angle 1 plus the measure of 2 plus the measure of 3 adds up to 180, right? Well, what if I had a quadrilateral? How do I know what the angles of a quadrilateral add up to? Well, our strategy for this is going to be to draw in one diagonal. Well, I'm actually going to draw in all the diagonals, but I'm going to draw the diagonals from the same vertex. So if I draw a diagonal here, essentially I've just created 2 triangles. So let's look at the angles of these triangles. Here's 1, here's 2, here's 3, right? So what do those 3 angles add up to? Well, since it's a triangle, those 3 angles add up to 180. And then we have 4, 5, and 6. But those 3 angles also add up to 180. Now if I take all 6 angles together, all 6 of those angles are really the 4 angles of the quadrilateral, because 2 plus 6 adds up to that lower left-hand corner angle. 3 plus 4 adds up to that upper left-hand corner angle. So if I add all 6, that gives me the total sum of the angles of that quadrilateral. So here we see the measure of angle, let me get my little angle symbol here. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. The measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 also is equal to 180. And if I add both of those 2 things together, I get 180 plus 180 is 360. So we'll kind of go over a shortcut of how to do this, but if I add all of these, 1 plus 2 plus 3 plus 4 plus 5 plus 6, in this case I get 360. So it's really, another way of saying that is 2 times 180 is equal to 360. Why 2? Because there were 2 triangles. So let's look at one more example, maybe 2 more examples. If I have a 5-sided figure, if I start from one vertex and I draw in the diagonals, how many triangles have I created? I've created 3 triangles. So let's look at the angles again. Let's place them in here. We have angles 1, 2, and 3. We have angles 4, 5, and 6 in the second triangle. And then we've got one more triangle, which has angles 7, 8, and 9. Now, we know that 1 plus 2 plus 3 adds up to 180, because that's a triangle. 4 plus 5 plus 6 adds up to 180, because that's a triangle. 7 plus 8 plus 9 adds up to 180, because that's a triangle. Okay, so we can see that if we were to add angles 3 and 5 together, I'd get the whole angle for the upper right hand. If I add 6 and 8 together, we get the whole big angle for the lower right hand. And if I add 2 and 4 and 7 together, I get the whole angle for the upper left hand angle. Okay, so this is great because that means if I just add angles 1, 2, 3, 4, 5, 6, 7, 8, and 9, I get the total of the angles of the original pentagon. Well, What did we say? Angles 1, 2, and 3 add up to 180. 4, 5, and 6 add up to 180. And 7, 8, and 9 also add up to 180. So that means that the sum of these angles adds to 3 times 180, which is equal to 540. You'll have to trust me on the math there. We can do the same thing for any sided figure. So here we have just one more. We've got a hexagon, 6 sides. So if we draw all the diagonals from one vertex, how many triangles are we creating? 1, 2, 3, 4. And, I've just got these measures in here so you can see them. Again, 1, 2, and 3 would add up to 180. 4, 5, and 6 would add up to 180. 7, 8, and 9 would add up to 180. 10, 11, and 12 would add up to 180. I don't know that you have to number all of these angles in your notes like this, but 10, 11, and 12 would add up to 180. We've got 4 triangles, so the sum of the angles of a hexagon would be 4 times 180, which is equal to 720. Okay? Awesome. So I'm going to stop the recording here because I'm kind of approaching my time limit. And then I'm going to record part 2, and you need to watch and take notes on both parts.